So welcome everybody. So we are a bit late because the API Machinery future talk by Daniel was just in the other building, so we were running and a bit. Deep dive. We have two topics mainly. I have some slides about CAD conversion, which we didn't show in the last talk by me and Mehdi. I will go over them first. Daniel has something about apply, server-side apply. Also a big thing for 2019, and then we just have Q&A. So if you have questions about those topics, but anything, I guess, just feel free to ask. So if I have focus, I might be able. There I am. Deep dive. So I think most of you have seen that. We have CAD conversion since 1.13 as alpha via webhooks, and I just want to give some slides answering questions which came up afterwards. So there was a question about ordering when there is conversion actually, and how this plays with admission and those things, and I will try to answer them quickly. So this is a pipeline of the API server, and CADs in this case, they come in here, go through authentication, authorization, and so on, and end up in the handlers. And CADs are JSON on the wire, so they're decoded, and admission is executed on them as for any other resource. Maybe there are webhooks called. And then there's the usual REST logic being applied, which might include etcd access and any other more complicated things. And then something is encoded again and sent back to the client. And conversion, so this is an old slide, a general slide, and there are some words conversion somewhere in there, and I highlighted them. So there are three places basically where we have conversion, and they play a role of obviously also for CADs, but not really. So those places would be candidates for conversion, where we call the conversion stack nowadays. But luckily, we did something. We don't have internal types. So if you know API servers for native types in Go, we have native internal types as well, and we have to convert a lot. For CADs, we didn't do that. For CADs, we have the request version everywhere in the pipeline. So you see this blue V1. Everywhere it's V1. In etcd, it might be V2. So the storage version might be different. And as you can imagine, a lot of those yellow bubbles just go away. You don't have conversion there. So CAD conversion is not called as much as for native resources, luckily, because obviously it's a failure or a point where an error can occur, or it's performance issues, latency, and so on. So basically, you have those two points there in the stack. On an update, we have to get something from etcd, and we apply something, so there is some conversion back and forth probably, so maybe 2 or 3, something like that. At the end here, there's nothing because we are already in the right version. On the webhook calls, it's the same. We are in the right version. It's just a non-conversion, so your webhook won't be called by those points. Patches are a bit more complicated, so patches have a retry mechanism internally, which means there might be n additional conversions, because each time on each retry you have to read from etcd again and convert. So patch is a bit more heavy, but still it's very contained at those two positions. We have watches. Watches are also versioned. There might be one more per version, which is not the storage version. So this is roughly the idea or the number which you can expect from the webhook for CAD conversion. I talked about internal versions. This is a picture here. This is for native resources, and there you see everywhere inside of this pipeline here you have internal objects, and everywhere on the side, on the edge, you have to convert. So this is very, very heavy, and conversion is so important for internal conversion. There's actually a discussion maybe to change that. Do we really need those internal types anymore? Maybe we want something called a hub type, which would also make this easier, maybe. The second topic about CAD is round-tripability. So I showed this slide. We do round-trip tests for native resources everywhere, very heavily. So on each change in the API, we run thousands of randomized conversion tests. So we just fill an object with random values, convert to another version via the internal version and back, and see that nothing was lost on the way. So round-tripping is very important, and we highlighted that like 10 times in the last talk. I just wanted to show, before you start doing that, we have patterns for that. So you find a lot of examples of round-trip tests in the code. They more or less look like that. So we use a library called GoFuzz, which gives you randomization of structs and references and slices and everything. Often it's not enough, so there is this fuzz no custom, so no custom calls here. But often you have to fix certain things, like you have to apply defaults. You can imagine if you don't have defaults and you convert to another version and back, and there might come in default values suddenly. So better default before. You will notice that very early on when you have those cases with defaults where round-trip testing fails, but it shouldn't. So it's pretty obvious that defaulting is missing. And also other type invariants. Sometimes you only support certain string formats, like some syntax in strings. But the fuzzer, of course, puts random data there, and this is not supported by your conversion, then you need to enforce certain type invariants. And by that, you create a list of those fuzzer functions, and we put them into a funcs slice, usually. And then we have a machinery, an API machinery, so some package called roundtrip, where we have a roundtrip test for API group. You give it the testing T and the install function for the scheme, those functions, and it just runs that 1,000 times or something like that. In all directions, with all versions, between all versions you have, all conversions you have defined. And that's basically it. So that's how roundtripability testing looks like in our code. And for CRDs, you can just use the same mechanism. Yeah, Outlook, I just repeat that. We showed it in the last talk already. A big topic is CRDs should be GA next year. And there's a big issue. Just look through it with 20 or something sub-issues which you have there. And those are the ones which are critical, so which we declared as being critical before we go to GA. There's a discussion in this issue. If you have a different opinion, go there and comment. That's more or less consensus at the moment. But yeah, it's one of the big topics next year to work on those. The first one is nearly done, so I guess in the next release we will have that. It missed 1.13 just by a few days, I guess. Quota, we have ideas. We had some implementation by Nikita. She is here, and we want another implementation where we have everything necessary. I guess now generic informers is a topic there. Default and pruning, there's a cap open. We have to decide what to do there next year. And some smaller topics, but that's basically it for GA. Yeah, so I will hand over to Daniel. Server-side apply is the second huge topic.
Yeah. Before I go on to server-side apply, I got a comment after the CRD thing and the round-tripability tests. I think it would be great to move those, like we have this CRD, we kind of have the starts of a pipeline that helps you define CRDs in the Kube Open API repo. So I think it would be really great if we could embrace that and extend it and maybe add something that generates the round-trip tests for you, or add a fixture that helps you round-trip test your conversion functions.
And this sounds a lot like KubeBuilder and Operator SDK.
Yeah.
There.
Yeah, I think Phil definitely has some plans there. So yeah. Anyway, I just thought it was important to mention that we're aware that like this is hard, and we'd like to give you help doing it. So I put together this server-side apply slide. I put everything on one slide. So how much detail do people want for server-side apply? Do you want like a lot of detail here, or just a little detail? Okay, I see some. Yeah. Okay. Lots of detail. Okay. All right. Cool. You don't know what you signed up for. Okay, so what have we been doing? We've been working on this since, I don't know, I put together the original design like Q1 this year, and then we've been working on it since then. And we did a lot of generically useful plumbing refactoring in API server. Like we refactored the patch handler, and actually as a result of that, we're able to, like, I spent all this time refactoring it, and then like Jordan deleted like a huge chunk of it because it wasn't actually useful. So that was great. And this makes our job easier. So, but what are we doing now? Well, I don't know, about maybe a quarter or so ago, maybe 4 months ago, the folks really working on it, which are Antoine, Police, Jenny Buckley, and myself, locked ourselves in a room and really tried to make sure that we had a shared vision for the design. I should say before that, Antoine and Jenny implemented dry run because we knew that was going to be very useful for this, and I had to be out of the office, paternity leave. I had to be out of the office, so they went and implemented dry run, and that is beta in 1.13, so that's pretty awesome. But then I came back and we're like, okay, we've got to get everybody on the same page. We really got to knock this out of the park now. So we hashed out the design. Antoine read all 50 pages of my original design carefully, and so then we sat down and we really argued about how to, is that really the best way to do it? There's so the original design, so the current design has this last applied annotation, which is like a JSON encoding of the entire object stuffed into an annotation. So it's everything is escape quoted, and if you're in a secret and you had some secret value, well, that's on the annotation. So it makes it hard to give people read-only or metadata-only access to your secrets when your entire value is in the metadata. So that's not good. And then the next design was like a formalization of that. Really explicitly defining the concept of what is a schema, what is a type, what does it mean to diff them, what does it mean to add them together. So I rigorously defined this three-way merge operation. So I mean I think that would have worked, but we came up with a slightly better design. Functionally, behaviorally, this is almost 100% the same. We won't be changing the test cases that we would have written. But the new design, instead of storing the exact struct or exact object, all the values intact, we've developed this data structure, which is a set of field owners. And and we've written this nice library that gives given a schema. The schema is still the same from the original design. Given a schema and an object, produce the set of fields that are set in that object, and then we are doing set operations on these objects to implement apply. So. I'll zoom in one more level of detail in a second, but the upshot of this is that we can store these in the metadata, and since these are just sets of fields, they don't include the values. So that lets us be both more compact in space, and we don't publish your secret details anymore in metadata. So. The way this sort of works is, let's suppose, and so there's two entry points into the apply, I'll call it the system, all right? There is the apply entry point where you're a user and you've explicitly said, apply this manifest. And then there's another entry point, which I'll call the update entry point. And this one gets triggered when you do a put or a patch, like an ordinary patch. And so the apply system does slightly different operations on these two things. This is another improvement in this design. Your controllers can continue to put or patch. You don't have to change anything about your controllers. So basically, I'll go through the apply path first. So you do an apply. The server takes your object that you sent, basically takes all the fields you set, strips off the values, and puts this into the data structure, which is like a try, just for efficiency. But you could logically imagine it's just a flat list of spec.replica, spec.template.containers 0.name foo. So all these things in this set. And it stores this in the metadata saying you own those fields. Now we allow multiple, it's not just a owner set in the metadata, it's also who is the owner of that set. So we can look at what's currently in the metadata and see, does somebody else think they own one of the fields that you're trying to set? And If somebody else does own that, we tell you, you actually need to force this operation. You need to explicitly say, I know some other component or some other actor in the system thinks that they're managing this field, but now I'm managing it. And this is to force the user to be cognizant that they're fighting with some other actor in the system. Okay, so that's essentially what happens when the user, and of course, if the user does force, then we take that field away from the other actor, add it to the user set. Now, the other way to enter into this system is through the update or put handlers. And for those, we assume that generally these are controllers, or if it's a user, the user is explicitly doing something for which they kind of know what they're doing. So the behavior for put or patch is like always force. Because if you're writing a controller, you're probably not prepared to begin receiving a new class of error message, right? Like hey, you're trying to take over a field that the user thinks they're setting. That's not a useful thing to give to a controller. It's just going to be like, oh, there was an error. I guess I'll try again in a second or millisecond. And that's not a useful thing. So we just always let the controllers win. And then the next time the user goes in, the user will get the warning, and the user will understand, oh, I'm fighting with the horizontal pod autoscaler over the value of spec.replicas. I should probably go turn that off for this thing, or maybe I should remove it from my specification document, right? Because probably you actually want the controller to keep on doing. You don't want to fight with it. And so that's those are the two entryway points into the system. I think that's a pretty, like if you want to go the next level down, maybe you need to go read our documents. So hopefully that's clear. So where are we on this project? And we were really hoping that we could get an alpha in this 1.13 release. Unfortunately, we got all the various pieces mostly done. I wrote a bunch of code for this is called the, I always say the name wrong. So it's the structured merge and diff library. So we wrote a bunch of code there. It constructs these field set objects, does all the necessary set operations. It's pretty nifty. It implements the logic behind apply. So that's done. And then when we started to glue it all together, we realized that we missed a couple pieces like in the glue. So it's actually calling into the system is actually easy. It is phrasing this new structure in the metadata. That is the thing Antoine and Jenny are working on at the moment. So our first draft was actually incredibly verbose. So we came up with a new format, and Jenny just showed me the proof of concept last night. It looks great. It's going to be very concise. And yeah, it'll be great. So hopefully that'll go in soon when I come back from paternity leave end of January. It'll be all in. I should say one more thing about this. One of the hard things about Kubernetes objects is we tend to do this thing with lists where it's not actually useful to index the list by number, right? It's not that you want the first container in the list. It's that you want to own a field for the container which has the name my sidecar, right? So the schema format and the way in which you name things, when you specify a list item, it actually understands that the name or some lists have multiple things, like the port list has both a port number and protocol. Like that, those two things identify that entry. So it understands that and it puts that as the indexing function. So that you own it, you continue to own it even in the face of reorderings or other things. So that is actually one of the main reasons why we have to do something special here. Why built-in tools like JSON patch, JSON merge patch are really insufficient for this operation. So we're working on the API. I think we'll have something that we're happy with very soon. I really don't see any problem with merging this back. And actually, I know we made this feature branch, and it looks like the amount of actual changes that are going into the feature branch will be fairly small for the for the feature branch. But it's good. It's a good habit to either commit a completely working thing or leave it not committed. It's good. So alpha 1.14 and like alpha, then beta, then eventually GA, hopefully soon. I think for beta, we'll want to make sure that this works for CRDs just as well as other objects. We've got some ideas for how can we make reasonable assumptions about the schema if you are a CRD author and you didn't actually add a schema. So I'd like to continue to support like some rudimentary amount of apply. Gracefully degrade. If you want the full semantics, you can always provide a schema. Next steps. What are we going to do in the future? Well, I think it's really nifty that we've got that we're not, as soon as this merges, we're going to have this great entry point into a subsystem that understands the object schema and what the user is trying to do to it. So I think an example of a really useful thing we could do here that we really didn't have the ability to do before, at least not in a clean way, is we could add something like discriminated unions. Brian Grant has frequently talked about this idea that our one of, it would be great if we had like a field, a discriminator field that told you which of the other fields was the one you intended to use. Like in the volume object is a great example when there's like this many different volume sources. So if we had a discriminator that said what volume you intended to use, like the subsystem could know to, like if you send it with this new thing set, we know that, hey, we should clear the others because you didn't intend to set the others, right? So if you have like for example, a client that didn't understand the others because it's an old client and some have been set new, and so you couldn't have cleared it because your client didn't understand that field. So that's just an example of the sort of thing that I think we can add here. Another next step, and I don't know if Stefan is going to hate me for this or not, but I really think the schema language that we came up with is more appropriate for defining Kubernetes-style resources than the OpenAPI spec that CRDs take today. Maybe this is just me, but I'm very concerned that OpenAPI lets you specify literally anything. So I like that the schema that we are describing these things in is much more constraining, because the Kubernetes API does not support literally anything. Like it's very much built out of the things we don't let you do. Because that's how you get consistency, is like you have to, the space of possible API objects is enormous. Like we've got to narrow that down and only permit a certain subset of that to enable interoperability and all the things you get with the Kubernetes API. So yeah, that was a lot of talking. Should we do Q&A? Yeah. Here, I'll walk around with a microphone and Stefan can sit up here and answer all the questions.
Mentioned the discriminated unions, but we specifically don't allow one of in the validation object currently. So what's the justification there? I think was a CPU intensive operation to do the validation check. With the discriminated union, you're saying that we would have a field that would tell us what to check for to see if it's set.
You're talking about the OpenAPI spec and CRD schema?
Correct.
Yeah. OpenAPI in particular lets you mix up schema level concerns with value level concerns, which are really two different phases in the Kubernetes pipeline. So Stefan can probably say more useful things about that.
One-off is performance reasons, so you can easily construct something which is exponential or something in validation, because OpenAPI has a strange behavior, or a strange property. It embeds logic, propositional logic completely. So that's why we exclude that. It's not healthy for validation performance.
Yeah. So if we did, for example, switch the schema like I was saying, then we could efficiently implement that. Yeah.
So with the server-side apply and encoding parts of the schema and who they're managed by, how does that interoperate with conversion, like going between different schemas?
Yeah, so that's a great question, and in fact, one of the thank you for asking that. One of the reasons why my original design did not involve the field set approach is because I thought we were going to be able to reuse the conversion functions. Unfortunately, the conversion functions, the built-in ones, all make certain assumptions about the object, like the defaults are set, which are actually not applicable to things that you run through apply, because apply is actually a subset of the object. It is not the entire object. It's just the fields that you want to manage. We realized that that was going to be difficult. David pointed this out. I had an approach, but after thinking about it carefully, and I wrote up a design that actually solved the problem without doing any conversions by doing a fancy, like doing extra operations on both sides, which I won't be able to reproduce off the top of my head, so you'll have to go look up my document. But the fun thing about the design is that it worked on the field set approach too. So it kind of, it's not that we went down the wrong direction, it's that we discovered this thing that unblocked the better design. So yeah, we won't have to call conversions. And basically, we let the user call the conversions for us. Yeah, it's fun. I saw, yeah.
Yeah, I have a question. What's the current status of, or the current thinking on custom sub-resources for CRDs?
Yeah, so there was some discussion about allowing webhooks for them. I guess this will solve most problems. There's no design written down. I think that's just missing. I'm not sure whether we have consensus that we want that. It wouldn't harm. That's my opinion.
Yeah, I feel like it would be nifty if the aggregator let you register, would proxy your sub-resources to you. That would let us move the existing weird sub-resources out to external components, which would make me happy.
So in one of the keynotes yesterday, someone declared that Kubernetes is boring, and all of this stuff looks distinctly not boring, and like the playing field is moving. At what point do you imagine that some of this will start to get boring and stable to the point where people, rather than looking at wrapping kube control to do their management, say, oh, hey, I can build a client, use client Go and get most of the same functionality?
Wow, that's yeah, I think our particular corner of the world is not going to get boring for a little while yet. I've got a long list of things to do, and I think we're a little bottlenecked both in spelling out the things we want to do and in people taking those things up and doing them and reviewing the changes, because there's actually not that many high-level reviewers for API Machinery, so we've got a number of bottlenecks. Yeah. So yeah, it would be. I would love for this stuff to become boring, but I don't see it happening this year.
Or next year.
Maybe not next year. I don't know. It depends on how far we get. Sorry. Yes, it's definitely not going to get boring this year. It's going to get more interesting this year. Okay. Yeah.
Sorry, I had spoken with Stefan about this before, but the validating and mutating webhooks are commonly also registered with CRDs. And now we have the storage conversion is actually configured on the CRD. Is there any possibility of being able to configure yourself as a validating and mutating webhook on the CRD? And then a follow-up would be, can we do a health check to see that the webhook is available and provide that in the status of the CRD?
Yeah, those were both good questions. Let me tackle the second one first, which is could we have health checks for these things? I actually, so in my role at Google, we operate many clusters. And so I have this sort of side project or idea is the control plane needs to be compartmental. I really need some areas of it to be able to fail without bringing down the whole thing. So in particular, these webhooks are a source of concern. But importantly, to the extent possible, I want the conversion or the admission control webhooks, I want them to be able to fail without bringing down the whole cluster. It may not be possible if you register something that does cover the whole cluster, but at the very least, I want the cluster administrator to be able to look at a dashboard and be like, these are all the webhooks that we're calling. This is like, I don't know, the last hour's worth of calls or something. This is the successes, the failures, the failure to reach it. Basically, I think the cluster administrator needs to be able to quickly route, see that, hey, something is broken. I go to the status page. This is the thing that's broken, at the very least. So a health check could help that. In a busy cluster, it's going to be called a lot, which is sort of the same thing, I guess. But yeah, and the other question was all those webhooks. That's a lot of webhooks. Couldn't we configure them all in one place, and maybe all at the same time, or maybe just say, hey, I have this component. I want it to handle all aspects of this. I think that's like an API design and upgradability thing, and also a security thing, because the ability to put a admission webhook on all resources of the system has security implications. But it makes sense to me that a CRD author should be able to register the things just for their CRD, and whether that means like an external component then goes and makes the necessary entries on their behalf. That's the most obvious way to do it. I don't know, Stefan, do you have?
I just remember that we discussed exactly this thing.
Yeah, we've definitely discussed this before.
Yeah. In the proposal for conversion, I think there was some chapter where we had long threads about that, whether it should be in the CRD or something like that.
We implemented it as a webhook, controller to watch for annotations on CRDs.
Yes.
So we would declare that we are the owner of that and auto-create because we didn't want every controller to have permission to register.
I think actually the admission control webhooks, the design, the objects there may need some tweaks in their design, because right now you register for particular versions of resources, which means that if you actually wanted to run on a deployment, no matter how the user sent the deployment to the system, you have to be careful to do that correctly today. So I think that we can do better. We just haven't had the this is kind of far down on our list of, we've got so much other things to do.
Is there any work being done on control plane fairness between clients?
Yeah, that is a great question. I think it is actually going to be a priority for us in Q1. My team specifically. I was actually wandering around to various other places earlier in the conference, asking folks, "Hey, why don't you come help us submit a design?" There is somebody has a KEP out. I know I asked for some changes on that. I haven't come back and seen the responses yet. I think David and I are mostly on the same page with what we need. This basically we want some sort of bucketing system, that's very cheap to take a incoming request, figure out what bucket it is in, and then some sort of quota system for the individual buckets. And it's not clear if you have multiple API server replicas. We don't want to. Yeah, it's a little we need to be careful to make sure that works right.
Yeah, that's a concern of mine too. I don't think quotas are going to do it. Fairness is different from rate limiting. You can't set the rate limits in a good way to get good fairness. They're separate issues.
Maybe I should say a little bit more. I think we actually need at least 2 tiers in the system. Tier 1 is like guaranteed, and the purpose of this is to make sure that your kubelet, your scheduler, your controllers always can get the QPS that they need, and then unused, like the API server needs to have some sort of understanding of how many requests it can handle, and so anything not consumed by tier 1 can be resold, I'll say, at tier 2, and that can be allocated more bursty manner, but it's not guaranteed. So yeah, definitely the design needs to be fair, have prioritization. There's like 2 other things that are a complete solution. Yeah. Does that make you feel better? Okay. I know that we've actually talked about this before, so let's make sure you'll see the design before we do things, and you can tell us if we get it wrong.
What's the plan for initializers?
Stefan, do you want to say that?
I think I heard discussions about removing them completely.
Yeah.
Not especially not in the other direction. Nothing about beta or so.
Yeah, so there's a specific proposal for namespaces to keep initializers for namespaces. I personally kind of feel like we should generalize it to all container typed, but we only have namespaces at the moment, so it doesn't really matter. But yeah, they're going away. Webhooks are a better experience for people.
I noticed on the slide about CRDs that at the very bottom you had local namespace CRDs as an undecided thing.
I have it here because it's requested so often.
Okay.
But I've not seen anybody who has an idea how to do that without breaking all the assumptions we have in API Machinery. So it's the last thing in open, undecided topics, and it's really undecided and totally open. So.
All right, we're over time, so maybe one last question I saw.
So like with the operator pattern and everything, there is the new use cases coming up where like third-party resources are being maintained by CRDs for things like Istio or something. The total number of objects may not matter that much, but the if the real use cases are for like maintaining thousands of third-party or like external resources, that scalability becomes a problem, as well as kind of like the backing up the objects in ECTD and everything. Are those concerns concerns of this SEG, or does any other SEG or any other group is looking at it?
Yeah, scalability is something we're aware of, especially if people make tons of objects. I know we have an entire scalability SIG. And we're also going to have to be concerned about this in our own SIG, because we at the very least, we own the API server to storage backend, like that pathway. Some ideas I have are like sharding, like make multiple shards so controllers can only watch a shard instead of having to operate over every namespace in the system. To get super big, we will have to improve etcd, I think, or do something. If we do it right, you can imagine an etcd cluster per shard, maybe.
Yeah, there's.
Yep. Plugging in your own storage is fraught with difficulty, but maybe.
There's just one thing missing. So we have some option, I think, some flag to redirect certain resources. It's unfortunately not used in the CRD server. So it's just, I would call it just a bug to use that. At least a simple use case of have a second etcd cluster.
All right. Thank you, everybody.